So you have f of x equals 1 divided by 2 pi f of x e power I omega x dx. This is ordinary Fourier formula. We know already Fourier transform formula. Now you substitute f of x equals e power minus ax squared here. So e power minus ax squared e power I omega x dx. Now one trick is that please be attentive. So you are going to add this one and you are going to subtract this. You are going to add omega squared minus 4a and you are going to subtract minus omega squared by 4a. Okay, the reason is we are going to make this as a squared one. We are going to make this as a squared one. See here, I repeat, you are going to add this one. This is in the power of exponential. You are going to add this one and you are going to subtract. The idea is we are going to make this as a squared one. So this is like a squared plus b squared plus 2ab formula. So we can change this as we can a squared a plus b whole square. So that's the reason that we have added this one and we have subtracted this one. Okay, we have added, we have subtracted this one. So e power minus ax square plus I omega x, we have added this one and we have subtracted this one. You just go with all the three, these three. We can write these three terms exactly like this, a minus b whole square. See 1, 2, 3. I have written the first three terms in terms of a minus b whole square. You expand this one, a minus b whole square formula, a square plus b square minus 2ab. You expand this one. We will have x root a. What is a square? X square? A. See, ax square. This one is your b. So b square will be, what is b square? You have minus, you have I omega divided by 2 root a whole square. See, this is your b, this is your a, and b will be, your b square will be I omega divided by 2 root a whole square. So I square will be minus 1. So you have minus omega square divided by 2 2s are 4. Root a multiplied by root a will be a. So you will have 4a. Is it okay? Then next one will be minus 2ab. Minus 2 minus, I have written minus 2 here, 2x root a. Your b will be this one. I have written exactly same thing. These two and these two will get cancelled. This root a will get cancelled. The remaining term I omega x. See here, I omega. I have pulled minus sign out. Here minus is there. I have pulled one minus sign out. So minus plus. See here plus. So I have written these three terms in terms of a minus b whole squared formula. Is it okay? I have pulled one minus sign out. So I am going to keep this as separate term and this as separate term. That's all. Then we can integrate and solve. That's the idea. So I am going to keep this as y. See here, I am going to keep this as y. So this becomes now. So just to differentiate with respect to x, that will give you, this will become 0. You have dy equals root a dx. So dx will be root y root a. So Fourier transform of f of x is 1 divided by 2 pi e power minus, what is this one? Y, we have kept as y. So y square. This remaining term as it is, same thing, because it does not contain x and y, it will be constant only, and the remaining term will be your dx becomes dy by root. Easier to solve. That's the reason. Now you pull all the terms out, all the constants out, except the term which is involved in y, with respect to y. So remaining term will be minus into plus infinity e power minus y square dy is in the integrants, and the remaining term will be 1 divided by 2 pi e power minus omega squared by 4a 1 divided by root a. Is it okay? Now e power minus y squared dy, so it's an even function, symmetry about its axis. What is the even function? You have to substitute y as minus y, you will get the same answer because y squared exists. That's called the even function, which you have already learnt. You are going to substitute y as minus y, you will get the same answer. So you substitute y as minus y whole square, answer is the same thing. So this is even function. You can write 2 times of 0 to infinity. Is it okay? Here it is minus into plus infinity. It's even function. So we can write this as 2 times of 0 to infinity e power minus y square dy. So easier to integrate this, taking the integral form alone. So now we know this formula, we are going to integrate in terms of gamma integral. Gamma integral often will be used in quantum mechanics again. So this is your gamma integral. You have to learn by heart. This is your gamma integral 0 to infinity x to the power n e power minus a x to the power m dx 1 divided by m times 1 divided by a to the power n plus 1 gamma. This is gamma integral. Gamma n plus 1 divided by m. You substitute n equals 0 here, x as y, a equals 1 and m equals 2. You will get exactly like this. We will get exactly like this. You substitute. Let us substitute. So n equals 0 means y to the power 0. Answer as 1. E power minus a x m. A is, the kept as a is as 1. M is 2. See e power minus y square dy. See here. This is what we want. See, therefore, integration of 0 to infinity e power minus y square dy equals 1 divided by m, 1 by 2. 1 divided by, where a will be 1 to the power 0 plus 1 by 2. So answer is 1. You have remaining term gamma 0 plus 1 by 2. Gamma of half. So 1 by 2 gamma half. Gamma half answer is root pi. You should remember. Gamma half answer is root pi. So you have 1 by 2 root pi. So root pi by 2. So we have found out only this answer alone. We have found out only the integral answer. So remaining term you have to write. Correct? Remaining term. So you have to write remaining term. And what is the answer of this? The answer of this is your root pi by 2. See, root pi by 2. You simplify all those things. 2 get cancelled. Okay. This root pi gets cancelled. You will have e power minus omega squared by 4a divided by root 2a. Okay. Now Fourier transform by f of x equals Fourier transform of e power minus ax squared, which is equal to, we have found out this answer, which is equal to this, e power minus omega squared by 4a by root 2a. Is it okay? Now Fourier transform of e power minus ax squared, they are all, ax squared is written as, suppose for example when a equals 1, a equal to 2, a equal to 3, we can give, so we have e power minus omega squared by 4 divided by root 2 when a equals 1. When a equals 3, you substitute, that will give you e power minus omega squared by 12 and this becomes root 2, 3, that will give you root 6. So it's very important problem. We have found out the Fourier transform of Gaussian distribution function. Very important problem. Now we will go for Dirac delta function. Dirac delta function, which is very important. Of course, we have learnt here already the concept of delta function. So we have learnt already the concept of delta function. Delta function, this is your delta function. For example, when you take delta function, always the peak value will be 1. The peak value of delta function will be 1. Where it exists. If answer exists in a peak function, the answer is 1. Remaining elsewhere it will be 0. See here 0 here. It is 0 here. Here alone it is, answer is 1. So this is your delta function. So minimum there will be 2 functions. Two variables. I repeat. Suppose you have x. X prime is somewhere here. When x prime tends to x, the answer is 1. When here it is x prime. Here it is x. When x prime tends to x, the answer is 1. Elsewhere it is 0. That's called a delta function, Dirac delta function. So Dirac delta function is given as this. Fourier transform of f of t equals 1 divided by 2 pi f of t e power minus omega t dt. This is Fourier transform formula, we know already. Dirac delta function, which is termed as Fourier transform of delta t minus a, which is equal to 1 divided by 2 pi delta t minus a e power minus I omega t dt. So this is nothing but your f of x for the earlier one. So this is the formula for delta function, Dirac delta function. Dirac Fourier transform of delta of t minus a which is equal to 1 divided by 2 pi delta t minus a e power minus I omega t dt, and whole thing is termed as f of x. The property that we have used is this one. The property that we have used is f of x delta x minus x prime del x equals f of x prime. So this is the property that we have used. So Dirac delta function of x minus a, which is equal to 1 divided by 2 pi e power minus I omega. Instead of x prime you substitute a here, so e power minus I omega a. So f of x delta, instead of x prime you substitute a, that will be your f of a. The answer is the same answer you will get as Fourier transform of delta x minus a equals 1 divided by 2 pi e power minus I omega. Instead of x prime you substitute a here, you will get the answer. If a equals 0, you will have 1 divided by 2 pi. So Fourier transform of delta of x equals 1 divided by root 2 pi when a equals 0. Now find the Fourier integral of the function f of x equals e power minus kx. Hence show that u sine ux by k square plus u square dE equals pi by 2 e power minus kx. So your f of x equals e power minus kx. We are going to show this one is equal to this. Okay, 0 to infinity u sine ux divided by k square plus u square du equals pi by 2 e power minus kx. We are going to show this one. The Fourier sine integral formula. Okay, the Fourier sine integral formula of function f of x is given by this formula. F of x equals 2 divided by pi f of t dt. So as usual, as I said, there are two domains t and x here. Here we have two t and x. F of t dt 0 to infinity sin ut sin ux dx. Now what is given there? F of x equals e power minus x. This is in terms of t. So you change into f of t equals e power minus kt here. So your f of x equals 2 divided by pi. F of t is replaced as e power minus kt dt sin ut sin ux du. We will just keep it as equation as 1. Okay. Now this term I have written u and all on one side, t on the other side. So that will become you have sin ut du, sin ux du. T terms on the other side, e power minus kt sin ut dt. We are going to integrate now. Okay, now we are going to take the second term and integrate. So this will become e power minus kt sin ut dt. This I can write this as this term. This is what we learned from the first video lecture. Can you remember? So sin ut can be replaced with e power iut minus e power minus iut divided by 2i. Can you remember this formula? Okay. Now you multiply this by this. You will get this multiplied this will give you this. E power minus kt multiplied by e power iut will be, I have pulled one minus sign out. See here, e power minus kt multiplied by e power iu will give you, multiply this and this. You will get e power ikt multiplied by e power iut. You combine these two and you will get minus sign out. Just pull minus sign out, combining you will have e power k, I have pulled t out. See e power minus kt, minus plus. So e power iut, see here first term. You multiply this term with this term. You will get minus sign is here and e power minus kt is here. I have pulled one minus sign out. So this will become minus into plus, that will be minus, see minus sign, e power minus iut. So multiply this term, you will get this term. Now it's easier to integrate. You can integrate easily. So e power minus k minus iu times t, after integrating will give you this. E power minus x will be integration e power minus x divided by minus 1. So similarly e power minus k minus iut by minus k minus iu. Integration of this one will give you this answer. You are going to integrate this, you are going to integrate this. See here, e power minus ik plus iu of t divided by minus k plus iu. The limits will be 0 to infinity now. Now this multiplied with this we will have to take the LCM. So this multiplied by this will give you minus minus plus, and of course a plus ib multiplied by a minus ib will be a square plus b square. So your k square plus u square, which we have learnt already earlier. Correct? See here we have k plus iu multiplied by k minus iu. K minus iu multiplied by k plus iu. The answer will be k square plus u square. And just cross multiply. First you multiply, take the LCM. After that just cross multiply. And this minus and minus plus. This minus and minus plus. So when you are going to cross multiply, it will give you e power ikt, e power minus ikt. I have pulled e power minus kt is common. I have pulled out. So remaining term will be k plus iu. See k plus iu. Remaining term will be e power plus iu. See e power plus iut. I repeat. This multiplied by this will give you this. First point. Second point will be minus minus plus. Then we will have to taking the LCM, we will have to cross multiply. So when I am going to cross multiply, this will give you k plus iu. You just separate. Separate, that will give you e power minus kt. Remaining term will be e power plus iut. Remaining term will be plus. Then you have to multiply this minus this, already it has become plus. So minus plus, that will give you minus. So k minus iu, and the remaining term will be e power minus iut, because already we have pulled e power minus kt out. This is okay. Is it okay? So just pull these term out. So 0 to infinity. Now we will have to substitute for t. So you will have to substitute for t as infinity. Now what we can do is, before substituting, we can pull again k out. So k e power iut, k times. Here also we have k times e power minus iut. See here, this becomes e power iut. This is here e power minus iut. I have pulled k out. So this becomes e power iut minus e power minus iut. I can pull iu out. So this becomes e power iut, and this becomes plus minus minus plus e power iut minus iut. Is it okay? So what of this one? This is your 2y sine ut, and that will be your 2 cos ut. I can pull 2y out. So 1 divided by 2y, I can pull 2y out. Remaining time I have written exactly like this. Now you substitute the limit. So when you are going to substitute the limit e power minus infinity, as I said, answer is 0. We will have to substitute only lower limit. When you are going to substitute the lower limit, this becomes, this becomes 0. Lower limit answer will be, okay, lower limit answer will be your u. So 2y will cancel. You have u divided by k square plus u square. Now we have done only for the integration of the second term. You have to write the first term multiplied by the answer for the second term. So multiplied by the first term multiplied by the answer for the second term. See, second term is this. So 2 divided by pi. This term we have already calculated the answer for the second term, and simplifying you will get u times sine ux divided by k square plus u square du. You pull all the terms, remaining terms out this side. So this becomes pi by 2 f of x. What is your f of x? E power minus kx it is given us. So this term which is equal to pi by 2 e power minus kx. See here, this is first asked. Show that pi by 2 e power minus kx is asked. See here. So this is what asked. Pi by 2 e power minus kx. Any doubt? Okay. Now we will go for the next one, convolution theorem. So very important property in Fourier transform. Convolution means, just you remember, this is a product of two signals, overlapping of two signals. We have two signals, we are going to overlap. We are going to have some product of two signals. So convolution means product. Just remember this one. Two convolution, minimum there must be two functions. When you are going to have a product, minimum there must be two functions. You just take f of x one function, you just have another function g of x. And f of x convolution. So this is, the star is termed as convolution. So f of x multiplied by product of convolution of g of x equals 1 divided by 2 pi. This is a formula, f of u g of x minus u du. The Fourier transform of convolution of f of x g of x is given as this. Fourier transform of f of x convolution of f of x and g of x equals Fourier transform after finding out. So this is the answer for this. Fourier transform of f of x is nothing but f of s. Fourier transform of g of x is nothing but g of s. So which is nothing but we have done separately. So here we have done convolution. Here we have done separately. So that's why I said it's a product. And Fourier transform of f of x is nothing but f of s. Fourier transform of g of x is nothing but g of s. Now we are going to prove whether it is correct or not. We are going to prove which is we are going to prove this one. Now we know that f of x dot g of x is given by 1 divided by 2 pi f of u g of x minus u du. We will just keep this as equation 1. So we know that the definition for Fourier transform is given as f of x e power I s x dx, which we learned earlier. Okay, 1 divided by 2 pi minus into plus infinity f of x e power I s x dx. Taking the Fourier transform of on both sides. Just take the Fourier transform. So Fourier transform of both sides of equation 1. So that will give you your f of x convolved with g of x, which is equal to 1 divided by the Fourier transform of f of x is nothing but f of x g of x e power I s x dx. Okay. So now you will have to substitute. You will have to substitute in this equation 1. So we will have 1 divided by 2 pi minus infinity plus infinity. So we can write this as f of u. See here, f of u g of x minus u. F of u g of x minus u e power I s x du dx. You separate. You just separate u this side and x minus u that side. So we can write this as 1 divided by 2 pi minus plus infinity f of u 1 divided by root 2 pi g of x minus u e power I s x dx du. So we have changed. Okay, instead of du by dx we have changed into dx du. Now what is the first one? F of u du, which is nothing but your f of u. What is this one? The Fourier transform of this. I repeat. See here, f of u e power I x. See, f of u e power I x du is nothing but your f of u. Fourier transform. This is your Fourier transform. What is the definition for Fourier transform will be this is equal to f of x. The Fourier transform of this one will be f of u. The Fourier transform of this one will be your f of g x minus u du. Now by shifting the property, there's one property is there, shifting property. This becomes f of u. The Fourier transform of this one is g of s du into e power I s u. Okay, so gs I can pull it out 1 by 2 pi. So that will give you f of u e power I s u du. So Fourier transform of this one will be f of s. Already this is your g of s. So g of s multiplied by f of s. Left hand side is Fourier transform of f of x gx. Right hand side is already we have found out the Fourier transform. The Fourier transform of f of x is nothing but f of s. Fourier transform of g of x is nothing but g of s. So this is what the convolution theorem is. So hence we have proved the Fourier transform of f of x g of x equal to f of s g of s. So this is what this is what asked. The Fourier transform of the convolution with f of x g of x is nothing but f of s g of s. So this is what we have proved. Okay, so we have come to the last section. Okay, find using convolution theorem. We are going to find inverse Fourier transform of 1 divided by 6 plus 5 is plus s square. Okay, so we have 6 plus 5 is minus s square. Just take the denominator, which can be written as 6 plus 3 is plus 2 is plus I squared s squared. Correct? This can be written as exactly like this. I split 5 is into 3 is plus 2 is. S squared I have split into I squared s squared. That's all. I have, see, I squared is minus 1, so minus s squared. Now this is asked, so you just write as it is. After simplification you write this. So f inverse equals 1 divided by 3 plus is 2 plus is. Is it okay? Now I can write separately the product of these two. I can write using convolution. So I can write separately. Fourier transform of this multiplied by Fourier transform of this. I can write this. What is the inverse Fourier transform of the first one? 1 divided by 3 plus is nothing but e power minus 3t ht. This is the Fourier transform of this. We can write h of t, you can write g of t, you can write m of t, whatever may be, doesn't matter. So this is the Fourier transform of this, e power minus 3t h of t. Similarly, the Fourier transform of this, so that will be e power minus 2t h of t. The product of these two, so you have to multiply these two, correct? So product of these two, you have to multiply these two. So this is your, you just keep it as f of t, and this is your g of t. And we have seen just now that convolution theorem, f of u g of t minus u du is given as convolved with two functions. You have this function multiplied by this function. So I repeat, you have f of u is nothing but this, g of t minus u is nothing but this. So you can write this as e power minus 3u, u is there, so 3u h of u, and this one will become e power minus 2 t minus u, and this becomes h of t minus u du. You just simplify, e minus 3u multiplied by e minus e power minus 2t plus e power u. So that will become, here you have e power minus 2 plus 2u, minus plus, already 1 minus 3u is there. So answer will be e power minus u, and you have e power minus 2t, you pull it out. So that will be e power minus 2t, e power minus u, h of u is here, h of t minus u du is here. Now we can integrate. The limits are given. See here, minus into plus infinity, limits we know that can be changed into minus into 0, 0 to t, t to infinity. So this becomes h of u, h of t minus u becomes, the limit will exist only in this interval, otherwise it is 0. So limit will exist only 0 to t. So 1, when u lies between 0 and t, answer is 1. So this becomes e power minus 2t, e power minus u du. So you have to integrate now. E power minus u, after integration that will give you e power minus u divided by minus 1. So you have minus e power minus u 0 to t. You substitute here, substitute limit, upper limit. So that will give you minus e power minus t. You substitute the lower limit, answer is 1, e power 0 is 1. 1 minus already exists, so this will become plus. So you have minus e power minus t plus 1. Okay, so just multiply, that will give you e power minus 2t multiplied by e power minus t, that will give you minus e power minus 3t. E power minus 2t multiplied by 1 will give you this. Okay, now the last problem. Use convolution theorem to find f inverse of this. The same technique that whatever we followed for the previous problem we are going to use. So 12 plus 7 is minus s squared can be written as 3 plus 4. So instead of s squared you can write this as I squared s squared, the same technique, and we can factorize this one. So 3 plus is multiplied by 4 plus is. So f inverse of this can be written as this. We can separately we can write as usual. We have done it for the previous problem. Now we will solve for the first one. So f inverse of Fourier transform of 1 divided by 3 plus is is given by e power minus 3t h of t. The same technique that we are going to use. So that will give you, the next one will be f inverse of 1 divided by 4 plus is is nothing but e power minus 4t h of t. So this equation 1 becomes multiplying these two. So this is equal to this and this. Okay, so now we are going to take, as usual, you are going to take this as f of t and this as g of t minus u, the same procedure. So that will give you f of u, g of t minus u, which is equal to e power minus 3u, c e power minus 3u, h of u, and this becomes, this is your g of t minus u, So this will become e power minus 4t minus u, h of t minus u du. The same thing here, minus 3u is here it is plus 4u, see, plus 4u, and here t is here, e power minus 4t, you can pull it out, and this will give you e power u, this multiplied by this will give you e power u. So you will have to have three integrals, minus into 0, 0 to t, 1 to infinity. This integral will exist in the limit, and this will become 0, this will become 0. You have this limit alone. So e power u 0 to e power u, after integration answer will be e power u itself. So e power u 0 to t. You substitute the upper limit, that will give you e power minus 4t multiplied by e power t minus 1. You multiply and simplify, you will get e power minus t multiplied by et will be e power minus 3t. E power minus 4t multiplied by 1 will give you minus e power minus 4t. So this is the answer for this problem. Okay. So that is the end. So we have already done many problems during this session. Fourier cosine transform we started with, then sine transform. We solved so many problems. Then Gaussian distribution functions, very important. Then Dirac delta function. At the end we solved convolution theorem and solved 2 problems. Okay. So thank you students. We will see you in the next class.